This is our lesson number 71, part 2 of Beware of Beryllium lesson. Part 1 was 70, lesson 70. This is part 2, lesson 71. How we identify beryllium treated stones and the technology what we can use. Please subscribe if you forgot to subscribe yet and share to all. These are the beryllium treated stones here. And here inside inclusions we can see in beryllium stones. This is also a very big stone here. We will discuss inside the lesson. Shall we move? This also lesson number 71 part 2, how we identify beryllium treated stones. These are the beryllium treated stones under the methylene iodide liquid vision. So we are moving to inside. An assortment of corundum following heating with beryllium. Note that while many now appear yellow or of orange, many remain blue. After the treatment, many remains blue and yellow and orange appeared. Here, this is web-like, spring-like inclusions. Check the inclusions. Web-like, spring-like, see the springs. These inclusions come in through the beryllium treated stones. It is very, very important. The web and spring-like inclusion is, we can see visible, often recorded in beryllium treated blue stones, blue sapphires. So remember, this is the main thing we can identify ourselves with the loop. This is an image example of beryllium treated blue sapphires currently on the Bangkok market. These are the beryllium treated stones in Bangkok market. See, all are beryllium treated parcels. There are 5 stones here. 5 beryllium treated blue sapphires selected as a representative sample from a larger lot purchased in Bangkok in March 2009. They are from left to right. Left one, 0.891 carat, small. Second one, 0.874. Third one, 1.101. Fourth one, 1.209. Last one, 0.8883. These are the samples we are discussing from here. We are discussing an example. You can identify easily. They had been sold as a beryllium treated blue sapphires. These 5 stones sold as mentioned it, beryllium treated blue sapphires. The price is very low. They were firstly analyzed using LAICP-MS. I need to explain you LAICP-MS technology. The meaning is LAICP-MS meaning is mentioned in the lesson number 70. Check it. Next, beryllium and other trace elements content we can find out with this method. LAICP-MS is the famous machinery technology. And here are the 5 samples, 3 spots. For example, this is the stone. Think 3 spots. 3 spots mentioned there. Depth of slice 1.03 millimeter. Old weight is this. Net weight is this. These are the places we mentioned here. Tiny spots, very, very tiny spots, heated by LAICP-MS technology. Then see what happens. 3 spots were chosen at random on the girdle. This is girdle, no? Of each stone for analysis, and the results are set out in table 1. Results are here. All of the stones were found to contain beryllium with some spots recording quite high levels. Some spots are high levels. The beryllium levels recorded range from 11.77 to 45.15 ppma. ppma means parts per million atoms. To count this, LAICP-MS method uses laser technology with the tiny spots mentioned in the girdle. It will heat up to 50,000 Celsius. It is very, very tiny, micro nanometer spots. So it is not visible. After that 50,000 Celsius, there the all atomic elements will count down with the system. LAICPMS is the system. Then we can mention what is the amount of parts per million atoms included there. The beryllium levels found to be present at 3 spots for each of the beryllium-treated blue sapphires depicted in early picture, plus the levels for titanium, vanadium, chromium, iron, and gallium in ppma, parts per million atoms. See the table here. There are 5 sapphires. Sapphire 1, 2, 3, 4, 5. Checked with tiny spots with the LAICPMS technology. The beryllium found beryllium 13.43 in the sample 1. Second one 15.87. Third one 27.36. Fourth one 14.27. Last one 29.45. It is very high rate. Magnesium rate is here in the 5 samples. 5 samples are mentioned here. These 5 samples, 1, 2, 3, 4, 5 are here. Then magnesium is present like this, ppma, parts per million atoms. Titanium ppma mentioned here. Chromium mentioned here. Iron, gallium, all are big amounts. Now we can go through. Beryllium-treated sapphire number 4 was polished. Number 4. This sapphire was polished down to a thin slice and sampled at 41 points by LAICPMS. This technology uses in 41 points inside the stone and check. Then LAICPMS to determine the depth of the beryllium penetration along with other element distribution. Note that the ablation spot to the far right was not included in the analysis. Far right is not included in analysis. Now this is the table we found. We can discuss it. To test the validity of the chemical data obtained at the surface of the faceted stones and realize the penetration depth of the beryllium used in the process. Stone number 4, originally an oval faceted stone weighing 1.209, was ground down and polished to a thin slice without shortening its greater dimension. The slice was then cleaned to aqua region 1. Aqua regia is the 1 to 3 mixture of nitric acid, hydraulic, nitric 1, hydrochloric 3 acid. So, in penetration for chemical analysis by LAICPMS, the slice was then analyzed at 41 points from the edges, girdle, culet, and table to the deepest points within the original phased stone. 29 points parallel to the original girdle and 12 points from the original table to culet. So, this is the picture. Then what happened? Other element levels were also recorded with niobium and tantalum having no concentrations. Niobium and tantalum, this is very important thing. Niobium and tantalum elements are included very tiny amount inside the sapphire. It is including with the nature. In stones that contain beryllium, naturally the beryllium tends to colorate with the presence of these two elements and potentially others, which is not the case for artificially retreated stones. In artificially treated stones, we can't find niobium and tantalum. In comparison with the titanium composition relatively high, magnesium concentrations were recorded for these samples, which does not fit well that the titanium 4 plus amount of ions are bigger than magnesium 2 plus beryllium 2 plus. So this is the scenario happens with the beryllium treatment. Beryllium and magnesium joined together with 2 plus ions closely related to titanium 4 plus ions. Earlier, because before the beryllium treatment, magnesium is very small amount, titanium is very big amount. Now the magnesium is joining with beryllium, increase in the level, then the titanium level very close to titanium level, then it gives the color. Scenario for lightning dark blue sapphires. This is the lightning dark blue sapphires as one of the reasons for treating blue sapphires by this method. Indeed, description. Indeed, the description given of the process amongst traders in Bangkok is the stones are darkened by the beryllium treatment and not lightened. Something that is either reported, conjecture, or a process we do not presently understand. Now look at here. There are 4 pictures here. Inclusions. The inclusion seen within an oval 0.891 carat stone. Stone number 1. Beryllium treated blue sapphire revealing indications of the high temperature heating environment it had experienced during the treatment process. Beryllium treatment process. Top left. Localized, created and altered healed fractures surrounding a myriad of crystal inclusions. Left. Top left. Top right, it is here. And bottom. Top right and bottom. Left. Top right, left. Melted previously crystals with shrinkage bubbles. Bottom right is this. Left is this. Melted previously crystals with shrinkage bubbles. Right, bottom right is a group of small previously crystals destroyed during the treatment process. These are the 4 pictures mentioned here. The inclusion seen within an oval sample stone number 2, beryllium treated blue sapphire revealing indications of high temperature heating. All images show the total destruction of individual crystals with top left and right, as well as bottom left showing that these are surrounded by fine clouds of pinpoint inclusion seen in reflected light from an optical fiber. What's here? The inclusion seen within an oval 1.0101 carat. Stone number 3. Beryllium treated blue sapphire revealing indications of high temperature heating. Top left. Traces of artificially healed tubes. Artificially healed tubes are mentioned here. Top right and bottom left, these two, top right and bottom left, circular and indistinct coiled spring. See the coiled spring like formations that have previously been reported as characteristic of beryllium treated blue sapphires. These two, this one and this one. Bottom right, look at the bottom right one. Heat destroyed crystals surrounded by fine clouds of pinpoint inclusions seen in reflected light from an optical fiber, as seen also here. See, heat destroyed crystals surrounded by fine clouds. Destroyed. The inclusion seen within an oval, stone number 5, beryllium treated blue sapphire revealing indication of a high temperature heating environment. This stone displays coiled springs. See the coiled springs displays, bottom left and right. These are the coiled springs, web-like formations, spring-like and web-like formations, bottom left and right, reported as being characteristic of beryllium-treated blue sapphires. Here, stone number 4. Stone number 4, after being polished to a thin slice, 1.03 millimeter. See here, immersed in diiodomethane. Diiodomethane is little bit higher Ri. No color zoning was observed. See, no color zoning. Either in terms of natural growth or surface conformal, the white area top left and the gray area bottom right just inside the edges of the stone is related to remaining facet reflection. This one, each of the 5 beryllium-treated blue sapphires we mentioned earlier were examined, immersed in iodomethane. Then the Ri is 1.74 to observe any color zoning that may be present. These are the things. No colorless rims. No colorless rims as observed and reported were found to be present in any of the 5 stones. Any of the 5 stones, no color rings. And the slight discoloration from blue to gray at the rim was also not observed in these samples, but beryllium treated. No other kind of surface conformal zoning was present. In any of the stone, angular blue color zoning was observed only in stone number 5. No blue color zoning was observed in stone number 1 to 4. All those straight brown rutile zones were noted in some number 3, as were brown hollows surrounding destroyed crystals in stone number 3. Colorless rims to heated blue sapphires in which beryllium was detected by researchers at the Gemological Association of All Japan in July 2003 left, where the rim appeared to be surface conformal, and July 2004 right, where the rim was not surface conformal. These are the 2 images. Fluorescence. All 5 stones were found to be inert to short-wave ultraviolet light, but fluoresced red to varying degrees under long-wave ultraviolet light. That is the beryllium-treated short-wave, long-wave. This red fluorescence was recorded in greater intensity using the diamond view integration 16 dB gain and a full aperture at full power. It is the apparatus. Then that is fluorescence. Stone number 2 in normal light left and the diamond view light right. Stone number 3 in normal light left and the diamond view UV right. Stone number 1, 2 and 3. 3 is here now. Stone number 4 in normal light left in the UV light fluorescence. Normal light, stone number 5 left, UV right. You can see the fluorescence. 2 large beryllium treated blue sapphires found in GIA. It was little surprising when beryllium was discovered in the heated 22.52 carat blue sapphire. Seen in here, 22 carat 52. And within a matter of days, this was followed with the submission of the 55% double 8 carats stone seen in next slide, where beryllium was also recorded. Tantalum and namibium, tantalum 73, namibium 41. It is the atomic number. Procedure in such cases requires that heated corundum is analyzed using LAICPMS technology, and that in particular, the concentration for beryllium, tantalum, and niobium are recorded. Beryllium, tantalum, and niobium are recorded. This is big one. Their trace element composition was analyzed using LAICPMS. 3 spots were chosen for analysis on each stone, and the results are set out in next. Both stones were found to contain beryllium with the levels ranging from 7.50 to 18.17 ppm, a very big amount. Naturally, come in 0.5 up to 1.5. Here, 7.5 up to 18.17 ppm, parts per million atoms. Counting done by LAICPMS technology after heating 50,000 Celsius in the tiny spot. Other element levels were also recorded with niobium and tantalum having no concentrations, indicating that the beryllium had been added artificially during the heating process. This is the number one thing. If it is natural blue sapphire, very small amount of beryllium may be present there. It is 0.5 up to 1.5 ppm. But other element levels were also recorded in niobium and tantalum levels are joined into natural stone only by the nature. When the man made beryllium treatment, man is doing the beryllium treatment. When doing the beryllium treatment, they can't add niobium and tantalum percentage like natural. So that is the main thing LAICPMS finding the beryllium treated stone. This is 55 carat blue sapphire sold. A blue sapphire recently examined in the laboratory weighing 22.52 carat was determined to contain 750 to 950 ppm of beryllium by using LAICPMS. This is the technology very high priced. Then here, to be concentrations in ppma in 3 spots examined to the 55.88 carat, very big blue sapphire. Beryllium treated blue sapphire depicted in earlier data collected by LAICPMS laser ablation in the inductively coupled plasma mass spectrometry. The name of this short letters. Sample 53.88 carat. There are 3 spots checked. Sample 1, spot 1 mentioned 13 beryllium in ppm. Natural ingredient should be 0.5 to 1.5, very big amount. Spot 2, the same stone, spot 2, 17.12 ppm beryllium. Spot 3 mentioned 18.17 ppm beryllium treated. Trace element concentrations in ppm. See the same stone, beryllium treated, blue sapphire depicted in earlier data collected by EDXRF. EDXRF, another one, energy dispersive X-ray fluorescence. Under that, beryllium treated blue sapphire, that 53.88, titanium is ppm is 38.3, vanadium 3.8, chromium 0.04, iron 168.07, gallium 19.98. So that is the EDXRF report. The beryllium concentration in ppma in 3 spots examined on 22.52 carat beryllium treated blue sapphire depicted in earlier data collected by LAICPMS. 22.52 carat beryllium treated blue sapphire. Spot 1 beryllium ppma is this. Spot 2 765. Spot 3 946. It is actually very big amount done by the artificial. Trace elements concentrations in ppma in the 22.52 carat beryllium treated blue sapphire depicted in earlier data collected in EDXRF. See, titanium is 84.67 ppma, vanadium, chromium, BDL, ferrous, gallium. So big amounts there. Here, EDXRF, energy dispersive X-ray fluorescence, is a fast technique used for bulk analysis where concentrations of elements sodium and above are desired. The same standards are used both for EDXRF and LAICPMS. Now we are moving to inclusion scenes. This is inclusion scene. A surface break-in heat altered healed fracture recorded in the 55.88 carat blue sapphire. It is beryllium treated. This is the inclusion. This is the inclusion. Beryllium treated this stone, very big stone, done by Sri Lanka people. Here, near surface feathering, near surface feathering, near surface feathering is here. You can see feather like. A feature often associated with heated sapphires, recorded in the 55.88 carat, that big stone. Beryllium treated blue sapphire depicted in earlier recorded this picture. Seen it is highly heated and beryllium treated. Fluorescence. Contrary to the smaller stones described above, both of these large stones were found to be inert or long wave and short wave ultraviolet light. It is inert. An image of the inclusion seen within the 5588 beryllium treated, that big blue sapphire depicted in earlier. It is, the stone is relatively clean internally and contain none of the inclusion types. This is the inclusion. None of the inclusion types. Here, for these two large stones, 55 and 22, the IR spectra were recorded with similar results, in addition to a peak at 3209 that is present. Peak is 3209. Figure 1. In the 5 smaller stones described earlier, figure 1 below. These large beryllium treated blue sapphires recorded broad peaks at 3112, 3057, 2628. Figure 2 and figure 3 there. Next. Then these spectra resemble the multi-band structure seen in some Punsiri type heated blue sapphires recorded in the past. That means Punsiri type heated blue sapphires are beryllium contained. So, in the infrared spectra, all 5 samples earlier discussed, a clear feature was recorded centered at 3209, this curve. Stone 1, 2, 3, 4, 5, all caves. Here, in addition to the peak at 3209, this is the peak. In the 5 smaller stones earlier discussed, this is 22.52 carat beryllium treated blue sapphire has peaks at 3112 and 3057 and 2628. It is figure 2. Showing a strong resemblance to the multi-band structure seen in some Punsiri type heated blue sapphires recorded in the past and to that of the 53.88. These big two stones also have the Punsiri type blue, heated blue sapphire, Punsiri type there. So, Ola, now the Punsiri type is heated blue sapphires are contained the beryllium. That is the decision. In addition to the peak at 3.209 that is present in the 5 smaller stones described earlier, This 53.88 carat beryllium treated blue sapphire has peaks at 3.112, 3112, 3057, 2628, showing a strong resemblance to the multi-band structure seen in some Punsiri type heated blue sapphires recorded in the past, and to that of the 22.52 sapphire described herein. This is figure 3. Now you can understand, you know what the beryllium treated stones, how recognize that. It is very hard thing and expensive thing. We are moving. You have to remember part 1 and part 2, everything. We are moving to heated inclusions in next episode. From the next episode, we are going to learn heated inclusions. If you haven't subscribed yet, please press the subscribe button and also click the bell icon. Always follow the lesson number. You will win.